So today we have 5 speakers in the first session, and it will be commencing with a very interesting presentation by Jonathan Crabtree. This Jonathan Crabtree has been deeply interested in knowing the development of Indian mathematics right from his school days. And he has been intrigued about zero, and I have had occasions to listen to a couple of talks in the web wherein he has been passionately arguing. So the contributions of India need to be recognized, particularly has been touching upon Brahmagupta. So once I remember himself writing to me about the verses of Brahmagupta, and I remember sharing with him the verses in Brahmagupta's Brahmasputa Siddhanta. Ever curious and addicted to discovery of zero, Jonathan began exploring the history of mathematics in 1983. As an elementary maths historian and podomatic creator, Jonathan is a guest lecturer at schools, universities, and conferences. His provocative presentations reveal how the foundations of Bharatiya mathematics are often superior to Western ideas taught today. So this is, in short, an introduction to Jonathan Crabtree. I invite Jonathan to start his presentation.
Thank you very much for your introduction, Professor Ram. As you can see, I've titled my talk, Notes on Brahmagupta's Definition of Zero Failing to be Transmitted to Europe. I'm going to define elementary maths foundations as concerning counts, measures, and relationships between quantities that reveal predictable patterns. So I'm starting off with a definition of number as numbers counting and measuring quantity, and also counts of absolute value, binary operations. So you're familiar with Brahmagupta's 7th century sign laws, as we just heard in the introduction, for positives, negatives, and zero. There we have perhaps the best critical edition, which I have made a digital copy of this 1902 edition of the Brahmasputa Siddhanta. If anyone wants a copy, it's available on my website. Here we've got from chapter 18, verses 30 to 35, where I've analysed with the help of several Sanskritists, and I've been able to then perhaps bring it to light based on my interpretation of mathematics from other cultures as well. So from chapter 18 on algebra, in my interpretation, 18 simple sutras of symmetry emerge that agree with basic laws of physics. So here we have Brahmagupta's 5 addition sutras or laws. We've got the Sanskrit up the top, and we've got the very simple laws of sign for addition involving positives, negatives, and zero. Nothing surprising yet. Here we've got the subtraction sutras as well. And what we start to notice is divergence from Western teachings on mathematics. And I'll get into that maybe a little later on. Here we've got the multiplication sutras, and then also the division sutras as well. So altogether, I've got 18 of these laws that I have been able to teach very young children how they all work. So despite this symmetric zero-based genesis, a brief cross-cultural review reveals an incomplete understanding of Bharat's zero in the medieval Arabic world. It appears that zero as a placeholder was transmitted via the Arabic world to Renaissance Europe, yet the role of zero as a number defined by Brahmagupta as the sum of equal yet opposing positive and negative quantities, it was neither grasped in the Middle East nor transmitted to Europe. We've got, in the 628, we've got Brahmagupta's definition of zero as the sum of equal and opposite quantities. And then it travels over to Al-Khwarizmi in the 9th century in Baghdad. And from there off to Northern Africa, it goes to Fibonacci and then eventually to Robert Record in England. So we see Robert Record here. Brahmagupta, I wasn't told about your zero definition or your 18 sutras of zero, positives and negatives. So what I'm saying is that the travel from east to the Middle East to the West was all about the zero placeholder, and there was never any acceptance of zero as a number of the same status of the other the numbers, and there was an absence of an understanding of negative quantities being equal and opposite. What the West came to be teaching everyone is that negatives by definition are less than positive. So neither zero nor the negatives appear involved in the development of Arabic algebra. So these sutras or rules are correct, yet 21st century maths pedagogies remain disconnected from post-Vedic Bharatiya maths. So the sutras are correct, and yet, and they're correct in terms of the laws of physics, but our pedagogies are not connected. So this talk reveals meta-mathematical disconnects and how they imperceptibly arose during the passage of time and place. As you can see here, when I've been analysing what I've needed to explore in elementary foundations of mathematics, I've had to explore in many languages. These examples here are of Euclid's definition of multiplication. And that was the problem that I noticed when I was in class 2 at the age of 7. I disagreed with my teacher, and I had picked up a major problem in the foundations of mathematical logic. If I survey people about which way is this ballerina circling, going round and round and round, around about 60% of people say that she's going clockwise, and about 40% of people say that she's going anti-clockwise, even though everyone is looking at the same image. So anyway, she spins both ways, and here are the two images, exactly the same image, but our brain picks up different spin rotations. So like mathematics, this dancer is spinning both ways based on our perception. So the mathematics that we've had passed on to us over millennia biased towards the right-hand side of the number line and biased towards what we consider positive quantities, and yet what's positive and what's negative is completely arbitrary. You're familiar with the answer, I'm sure. For every action, there's an equal and opposite reaction. So what we're starting to see in the laws of physics is when we assign numbers to the only things that are in the universe, which is matter and energy, numbers can only represent positive quantities of energy and positive quantities of matter. And so we start to see that there's a symmetry in physics disconnected from integer ordering logic and much else. We've got one negative electron and one positive positron. They sum to zero. They cancel out each other out. They annihilate each other, release a little bit of energy in the form of a photon. But we have one negatively charged particle, one positively charged, and they sum to zero. And we don't say that a negative electron by definition has to be less than a positive positron, but that's what our elementary mathematics education would have us believe, which is not how the universe works. So symmetry is when things are the same around an axis. So seeing symmetry and discerning when it breaks is a key for understanding both mathematics and physics. So if we consider the Big Bang, it's almost as if shunya was decompressed, creating infinite magnitudes and multitudes from zero. if we consider some of the aspects of physics, we've got the zero-sum universe. We've got the conservation of matter and energy, and we've got Newton's third law. And all of these aspects go into Brahmagupta, Bhaskara, Symmetry, and Podometic. So what I'm doing is I'm building a system of mathematics to replace arithmetic. That's what I set out to do in 1983. I decided to fix mathematical foundations and create my own mathematics. So if you search on Podometic, you'll probably see lots of things online. But my goal is that the new curriculum of Podometic Bharatiya mathematics might one day start to slowly get into the Indian foundational curriculum from Anganwadi up to class 5 at least. And even if children in class 1 get a grasp of these, from class 1, children will start to understand positives and negatives intuitively and very simply. So if we've got planet negatron and we've got planet positron and we've got a body in the middle, what we have again is the two opposing forces sum to zero gravity if we're in between those two planets. So whenever opposing quantities of forces or directions are equal, you're going to find zero. But this sense of symmetry of force and matter never came through ancient Greek geometry, and I'm going to move on to that shortly. So here we've got the elements of a basic number line, and here I've coined a phrase, the 0-point choice. So here we've got some artwork, famous artwork from Escher, and what I've done is I've put on a couple of rulers into the hands. But what we have when we consider construction of geometric diagrams and also proofs is we have to make a choice from the first point that is drawn, and I call it a 0 point because, as you know, in Greek mathematics, a point has no magnitude in any of its 3 dimensions. So it is effectively, in Greek geometry, a local 0. So we've got the 0 point choice, and that means that whenever we draw a point for the construction of our geometry, we have to, from that point, decide which direction do we go. And it's an arbitrary choice. And we see through the history of mathematics that there have been many arbitrary choices that became laws and rules. What we then can do is revisit proportion, and proportion is the key that unlocks the language of the universe, and it also unlocks our mathematics as well.
Isaac Newton's 1687 Philosophiae Naturalis Principia Mathematica, the mathematical principles of natural philosophy, where natural philosophy means physics, presented laws of motion, universal gravitation, and more. There are 44 additive words in Principia compared to 396 proportional words.
So now I'm going to move on to Al-Khwarizmi's equation types to start to demonstrate how Barat's 0 did not get understood in the Middle East. Arabic algebra entailed steps to arrive at co-equal polynomials. So the following is an anachronistic styling as modern equations. So we've got equation types such as ax squared equals bx and ax squared equals c. Al-Khwarizmi talked about balancing equations, and the Arabs were great traders. So I've, in my own mind, had a balancing metaphor of using balance pans. And so we can see that ax squared balances it confronts bx, and ax squared confronts or balances c in these equation types. And there are more equation types that Al-Khwarizmi had. Bx equals c, ax squared plus bx equals c. But what we notice missing is we don't have negative quantities appearing on their own. So nowhere in Al-Khwarizmi's or Arabic algebra, for that matter, do we find equations such as ax squared minus bx equals negative c. And in the balancing pan metaphor, you can understand how could you have positive quantities on the left balancing with something that's, in our own interpretation, less than zero. It doesn't make any sense, and it didn't arise in the Arabic algebra. And also, what we also know is that ax squared plus bx plus c balancing to zero also didn't emerge out of the Middle Eastern approach to algebra. And yet we know that from Brahmagupta, he gave us those laws of sign in his chapter on algebra. And so whilst negatives and zero were incredibly well documented in Bharat's algebra, there's no evidence of it being transmitted to the people who then passed on Hindu mathematics to the West. So negative terms did not occur in Arabic algebra, yet today you wouldn't know that. But we see the phrase algebra in the title, and algebra, as you know, morphs into the word algebra today. So we know that this title becomes something like the compendious book on calculation by completion or restoration and balancing. In mathematical language, the verb jabra means to transpose negative quantities to the opposite side by changing signs. But and I've just got many examples of this where lots of different commentators keep talking using negative terms, but what's happening is there are no negative terms in Arabic algebra. All they are positive terms being subtracted. So if we go back to the addition sutras, what was documented in India, only one would have been understood in the Middle East, because all the other four sutras were referring to zeros and negative terms, and that's not what was understood in the Arabic world. So here we've got all of the sutras, and this is the one that's the most important that needs to be reworked into modern curriculums. Addition Sutra 4, when positive and negative are equal, the sum is zero. So there we've got a zero. We've got, and there's another zero. We've got two positives and we've got two negatives, and that is a definition, a quantitative visual definition of zero. So if we take away the two positives from zero, you can see with your eyes that you're left with two negatives. If again from zero, we take away two negatives, we see with our eyes that we're left with two positives. So we can start to see very simple visual instantiations of Brahmagupta's sutras, and they go all the way through multiplication and division as well, with fun games for children in class 1, 2 and 3. So we can add integers to zero, and that's what I've got here with a reworked number line in which we have symmetry restored. So we have positives on the right, we have negatives on the left. What we can then do is we can also subtract integers from zero, and then we have this sort of concept, which again is pure symmetry, and from this we can then develop what's called a Brahmaguptan plane. So as I'm short on time, I don't have the opportunity to explain how it works, but essentially we pull apart the operations of arithmetic and separate out the quantities as the multiplicands and the multipliers as the abstracted numbers, and we start to then have a very simple model where children can understand what's going on with multiplication across all 4 quadrants of what we know as the Cartesian plane. I do have a paper all about the Brahmaguptan plane, where I go into great detail and also discuss how we could have developed geometry out of negative and positive areas as well. And we can do that dating back to Egyptian geometry. So what we need to do is to bring in negative line segments. We need to have in negative areas and negative volumes. And all of these things become very intuitive for children when we correct the foundations that were broken, typically in Europe. So I'm going to just whiz through these. I'll make available this PowerPoint presentation to people who choose it. But here we can see the Brahmaguptan plane in the 4 quadrants, and it's a very, very simple concept. We're in quadrant 1. We've got 8 positives added 3 times to 0. In quadrant 2, we've got 10 negatives added 5 times to 0. And that's what was missing. In the West, they never had the accumulation or the subtraction from 0 in their definitions of the algorithms. So Euclid didn't have 0 or 1 as number, and therefore, believe it or not, the identity elements of 0 and 1 were then missed from definitions of algorithms in Europe, as crazy as that may seem. So we've got some things which work with Western mathematics, and we can give it a thumbs up, but we also have some things which do not work and break the laws of physics. So just very quickly here, Brahmagupta says that when a smaller is subtracted from a larger, the sign stays the same. And so with 8 negatives minus 5 negatives, the 5 negatives are smaller than 8 negatives, and that's why the sign stays the same. And we have 3 negatives as the answer. And yet the West would say that negative 5 is greater than negative 8, which is not correct logic. So again, Brahmagupta says that when a larger is subtracted from a smaller, the sign will change. And so we see that with negative 3 minus negative 7, the sign changes and the answer becomes positive 4. So negative 7 is actually larger than negative 3, according to the laws of physics, according to Brahmagupta, and according to common sense. A debt of 7 rupees is greater than a debt of 3 rupees. So we've got the actual quotes from the people in the Middle East, with Al-Khwarizmi talking about, I had seen that the Indians had set up 9 symbols in their universal system of numbering, and every number is put together above 1. So Al-Khwarizmi doesn't mention 0, and also he doesn't even accept the number 1 in the set of numbers. And we go from him, we go to Al-Euclidisi, and again he mentions 0, but Al-Euclidisi, the Euclidist, only mentions 0's role as a placeholder. And again we see a very strong Euclidean influence in this time in the Middle East, which prevented the proper understanding of 0. Now we can then go on to other Arabic writers as well, and none of them really put 0 up there in the realm of number. And on it goes. So what we can do is we can say that with the birth of the Cartesian plane, 1,000 years after Brahmagupta, we look at the original diagram from La Géométrie, and this is what led to the Cartesian plane. But we don't have, and there's nothing overly new here. This is Euclid from book 6. But we've got line segments, and this is for the model of multiplication. So what we can then do is put this into a GeoGebra applet, and we can then use similar triangles to work out the products of multiplication. This was the good idea that got us off the area model. And so we've got a blue multiplicand, we've got a green multiplier, and we've got a red product.
Yeah.
And that is that when we have the concept of negative magnitudes, which is very much an Indian concept with zero mediating left and right, positive and negative, we have a geometric model for negative magnitudes, a negative multiplicand and a negative multiplier producing a positive product. So we can go back and revisit all of Euclid's work, all of Descartes' work, and lots of algebra with the concepts from ancient Bharat, and then suddenly a whole lot of simpler mathematics starts to emerge. So thank you very much for watching.
Can I ask a question, Professor Ramswamy?
Yeah, yes, please.
You have very beautifully sort of told us how negatives and zero, the physicality of them was completely missed in their transmission to West Asia and to Europe. But I'm sure this continued in Indian mathematics. Brahmagupta pioneered, and there were so many Indian mathematicians. So have you seen anything in them where this sort of this physicality, how it sort of reflects? I know that Bhaskara says Ranatvam Vyatyayena, Vyatirekena and all that, the kind of idea you are saying. But how does it in pedagogy, etc.? There are so many beautiful textbooks written in India. They must have used the Brahmagupta method.
Look, I would say that there hasn't been a whole lot of proportion work across positive and negative that I've come across from the Indian writers. We do have Krishna who very much speaks about if, for example, East is positive, then West is negative, and that's in the 16th century. But really the problem came with the writings of John Wallis in 1685, who created a number line where going backwards instead of retreating, and where advancing is positive and retreating is negative, if you are forced to go backwards, John Wallis said that we've advanced less than nothing. And that introduced the absurd idea of negative magnitudes being less than zero. The main problem is that the writings of Aryabhata and Brahmagupta and Bhaskara weren't translated into English until the 19th century, around about 1816, 1817, with people like Taylor and Colebrook and so on. So the pedagogies in the West had been well and truly locked in. And remember, you also had the Macaulay education policy, where all of the wonderful opportunities to teach in Indian mathematics in the last couple of hundred years were wiped out by teaching a British mathematics curriculum. So look, I haven't seen a whole lot of basic mathematics texts that go into the operations and the simple geometry of positive and negative. I would love to find it. I haven't found it yet. I'm very, very curious about everything that involves the foundations of maths up to algebra. I don't really go into trigonometry and calculus because I really wanted to get the elementary mathematics foundations realigned with the laws of physics. And we just see that the Indians were astronomers, so they were empirical observers, and their numbers had to match their science. And unfortunately, the West got their maths from the philosophy of Aristotle that led to what could be done with geometry. And really, it was an esoteric art that had laws and rules that had to be enforced in the face of the logical foundations that both China and India had.
Okay.
I have 6,000 manuscript. If you are interested, I can introduce to you.
Yeah, okay. I think we may have to close this talk session. We thank the speaker for presenting a very interesting talk which invited a lot of attention from various audience.